I have to carefully analyze the system. So the block will climb up. So initially, what is the state of this? This is at rest. All the surfaces are smooth. It's telling. Now, what are the sequences that will take place? So the block starts climbing on the wedge. At the moment the block starts climbing on the wedge, what conditions will come? Normal contact. All these are really diagram based questions, so student has to fight with a diagram. Let me bring on the sequence of diagrams. This what finally I'll show a complete description. This will be very fundamental and very important for students to analyze this one. Conservation of linear momentum, the velocity of center of mass, all those ideas. What actually happens here? So the block initially a very good problem of conservation of linear momentum and center of mass. I think okay, all the sequences are there in front of us. No. Let's begin that one. So this was having initial velocity u. This wedge was at rest. Now it starts climbing. The moment it starts climbing, what are the forces? Everyone please put effort, try to understand things. Here normal contact, you start with this one. N1. M1g cos theta, M1g sin theta. And it will have some velocity, say, with respect to, let it be wedge only. So with respect to ground, it will have some velocity. URL, right, with respect to wedge. Then N1 will also act on the wedge. And because of N1 sin theta, what do we expect the wedge? Wedge will start moving. Means the moment the block starts climbing onto the wedge, N1 sin theta will act on the wedge. And because of that N1 sin theta, the wedge will start moving towards right. So this will acquire velocity, say v2. Okay, fine. Okay, now how long this will occur? Now the weight m1g sin theta, what it does? It will make this velocity of the block with respect to wedge will start decreasing. At one instant, both will have common velocity and will be moving towards right. Still continue same thing. N1, this N2. The weights are acting. Then it will come to rest with respect to wedge. Then on the from ground frame, when you see what will happen, both are moving with a common velocity. You are going to see that. Then, so because of component of weight, now the block weapon will start moving with respect to wedge. Now, if you stand on the wedge, the person on the wedge, what he says? Block is at rest at this moment. Person on the ground, what will be comment? both block and wedge are moving. At this moment, only at this moment, at that instant, for a fraction of time, it will be, this will happen. Person on the wedge says, yes, the block is attached. Agreed. Now again, what will happen? M1, this person, what he says, M1G sin theta will start acting. So now what is the motion of the block? The block and the wedge will continue to move towards right. Okay, V2 dash you write it, or V3 sun. Then finally, this is what happens. Okay, I think. Finally, what happened? The wedge will be moving towards right, and the block will be moving towards left. In all the cases, anything will happen to velocity of center of mass. The center of mass in what action? Because what is the net force on system along x-axis? N1 sin theta. Here also you write N1 sin theta. Students, they don't want to draw diagram, that is they want answer. That's why I have to show all these things. Otherwise, we have done so many problems in laws of motion. You are supposed to think. Only teachers should say that net force on system along x-axis 0. How it is 0? By the time students should have all this background. See, where you are going wrong. I am scolding very bluntly so that you should get hurt and you should realize something, there is a big problem is there. Actually, how I should solve the problem? Teacher just should say that the net force on the system along x-axis is 0, so therefore you can apply conservation of linear momentum. This idea, this is enough. As a teacher, I should teach only, physics teacher, I should teach only this much here. But there's a problem. Sir, are you want to get rid of your job? No, my job is not to dump numericals. I should make you to think, no, but that thinking from your side should come, not from teacher's side. Look at here at all the sequences, N1 sin theta, N1 sin theta, N1 sin theta, N1 sin theta. Everywhere, the net force on system along x-axis is 0. Can we apply conservation of momentum? S. M1 U should be equal to minus M1 VA plus M2 VB. Can we calculate? S. We have all the information. So, but sir, both are unknown. What to do? Can we apply conservation of mechanical energy? Net work done by normal contact on the system will be 0. So, who is the only? Then the weight also. Weight is the conservative force. So, net work done by gravity also 0. So, therefore, the kinetic energy of system will be conserved. So, M1 U square should be equal to M1 VA square M2 VB square. Like this, I think solving equation 192, we will get this final velocity. What about the center of mass? Center of mass will continue to move in the same direction. Nothing will happen to it. Center of mass of system somewhere here, for your understanding I'm putting here. In all the diagrams you just show it, center of mass will continue to move its same velocity as if nothing is happening. Center of mass doesn't bother, like it will just the block has ascended, descended, it will try to continue to move, but it will not be here. So look at here, center of mass, where the center of mass of system has to be here. No, it has climbed up, it is somewhere here. No, but it will continue to move. With what velocity? With a common velocity. How to calculate that common velocity? How to calculate this velocity? Because it will rise to a certain height. You look at the block has rise to certain height. Let me show by its other color. Then applying again m1u equal to m1v plus m2, and this v equal to m1u plus m1 m2. This is nothing but velocity of center of mass, no? Any reason for that? Net force on system along x-axis 0. Then how to calculate the height to which it will reach? Do we have formula? Yes, we know v from here. So the initial data is given. So to what height it will rise, that also we can calculate it. What is the question? Find maximum height ascended by block A on wedge. That is what that h. So what is h we should call? Maximum height so again the block will not be there only because of m1g sin theta, it will start sliding down. So in all the sequence here, center of mass will continue to move with a common velocity, will continue its velocity, uniform velocity motion, as if nothing has happened, as if the block has not climbed anything. So I am writing UC now VC. Okay, we'll do one thing. Same symbol will continue. Make observation. Any doubt you can clarify. Any doubt if you have, you can clarify. The complete problem description is available. Next question. Sir, if the surface between the block A and the wedge, if the inclined plane is rough, still can we apply conservation of linear momentum? I want answer from students. If the inclined plane...
Yes.
Yeah, we can apply it. But can you apply conservation of mechanical energy?
No, sir.
No, sir. Non-conservative.
Non-conservative force does work. These are some observations one has to make here. Whether inclined plane is rough or smooth, momentum is conserved. Mechanical energy is conserved only when all the surfaces are smooth. Inclined plane smooth, momentum, mechanical energy is conserved. Inclined plane is rough, momentum is conserved, mechanical energy not conserved. Inclined plane is smooth. Both momentum and mechanical energy is conserved. Momentum is conserved and mechanical way to write this is not conserved. This I'm telling this one, this chapter is especially this conservation of linear momentum. No, you have to pick up some best numericals which are diagram based, not like some particle, some equations. Okay, fine, it's a mere mathematics here. You have to pick up numericals where some wedge, block, springs are there, strings are there, some various different forces are acting, how momentum is conserved. Finally, that is what matters a lot, not just mere some equation.